Hello students, welcome to KSMP Academy. Today we are going to discuss electric charges and fields. This is the first unit of the class 12th. So let us first see what is electric charge. So you see, it was observed by the scientists that there are many such materials in this universe which when rubbed they could attract some other objects like straw or pieces of paper. It was observed that if two glass rods are rubbed with the silk or wool and brought close together, then they repel. At the same time, if plastic rods are rubbed with fur and brought close together to glass rod, then they attract. So that means there are two kind of materials. That is when they are rubbed, then they can attract or repel each other. So therefore, it was concluded that these materials are charged. And there are two types of materials and there are two types of charges accordingly, so that objects are attracted or repelled. So this was the introduction of the phenomena of the charges. It was observed when glass rod is rubbed with silk, glass rod get one kind of charge and the silk of other kind of charge. So charges are basically in a pair. That is one kind of charge on one material and another kind of charge of second material. So when this charged pair, that is glass rod and silk, they are brought together in contact, then they neither attract nor repel. So it was concluded that the unlike charges acquired by rubbing the objects are neutralized. So that means when these two kind of charges are bringing together, then they nullify each other's effect and objects are brought when in contact, then they are neither attracting or nor repelling. So these two types of charges are known as positive and negative charges. So let us see the basic property of the charges. So if the size of the charged bodies are very small as compared to what? The distance between them. That is, there are two bodies and they are charged. So if the size of the charged bodies are very small as compared to the distance between them, then we treat them as point charges. So in the further discussion, we will be assuming that there are point charges. So that means that their size is very small as compared to the distance. And in that case, we assume that the total charge content is concentrated at one point in space. That is considered as point charge. So one property of the charges is additivity. So if a system is having more than one charges, then total charge is obtained by adding them algebraically. That means you see the example, if we have a system of charges having charges as Q1, Q2, Q3 and Q4, then total charge in the system will be the sum of all the two, algebraic sum of all the four, that is Q1, Q2, Q3 and Q4. So we have to add algebraically. So if a system is having n number of charges, then this will be the expression for the total charge, that is Q1 plus Q2 plus Q3 plus Q4 and Qn. Here total charges are n in the system, n is the number of charges. So here we have to remember that these are to be added in algebraic method. That is, suppose a system is having charges as plus 2 coulomb, minus 3, plus 5c and minus 8c. Then total charge will be the algebraic sum, and if you see, the total charge in the system is coming out to be minus 1 coulomb. So we have to add using algebra, that is in algebraical method we have to add these charges. Second important property is the conservation of charges. When the objects are charged, then electrons are transferred from one object to another object. That's why these two objects are charged. One is positive and another is negatively charged. The object which is receiving the electrons will be negatively charged, and the object which is releasing the electrons will be positively charged. So these our electrons are just transferred from one object to another object. These are not created or destroyed. Both of these objects will be equally charged, but with different nature. That is, one with positive, another with negative. So with this we can say, or we can conclude, that in an isolated system having charged bodies, charges may get transferred but not created or destroyed. That means there is a redistribution of the charges only, but total charge will always be same. That is known as conservation of the charges. That is, total charge is always conserved in an isolated system. It may be redistributed, it may be transferred from one object to another object, but again we are repeating that the total charge remains always same. That is, we say charges are conserved. Quantization of charge. It was established experimentally that all the free charges are integral multiple of the basic unit of charge E, which means we can write a charge to be given as Q equal to NE. Here N is what? N is integer. It may have positive value or negative value. This is known as quantization of charge. And charge of electron is taken as negative, that is minus E. On electron, charge will be minus E, and on proton it will be plus E. So charge on proton is plus, charge of electron is minus, and unit is E, basic unit, so minus E and plus E. SI unit of charge is Coulomb, and it is what? 1 Coulomb is the charge flowing through a wire in 1 second if the current is 1 ampere. That means if in a wire a 1 ampere current is flowing, then 1 Coulomb of charge will flow in 1 second. And the value of E is 1.6 into 10 to the power minus 19 Coulomb, that we are going to use frequently. And we can find the number of electrons in 1 Coulomb of charge, and there are approximately 6 into 10 to the power 18. So in 1 Coulomb of charge, there are 6 into 10 to the power 18 electrons. That can be established and can be calculated. Now let us see the fundamental law of the chapter, that is Coulombs law. So this law is the experimental law formulated in 1785 by the scientist Coulomb, and it is basically giving that there is a force between the charges. So let us see how it gives that fact. So here again we are saying that we are considering point charges, and we have already discussed that point charges means when the size is so small as compared to the distance, then a charge is known to be a point charge. For example, a collection of the charges on a pinhead, it may be considered as a point charge. So we consider that total charge is concentrated on one point. So let us see that how this will now give the force between the charges. So let us assume that there are two charges. One is Q1 and another is Q2 and they are placed by a distance R12 here. The magnitude of the distance we are considering to be R. And with respect to origin, the position vector of the charges here is given as R1 and R2. So according to this law, the forces between the 2 point charges Q1 and Q2 is along the line joining them. The force is directly proportional to the product of the charges Q1, Q2, and force is inversely proportional to the square of the distance R between them. Mathematically, we can express that the force is directly proportional to Q1, Q2 upon R square, or force is equal to K Q1, Q2 upon R square, where K is a constant, of proportionality. So F is K Q1, Q2 upon R square. Value of K in SI unit is 1 upon 4 pi epsilon naught. Here epsilon naught is the permittivity of the free space, and its value is 8.854 into 10 to the power minus 12, or we can write in this form, that is 10 to the power minus 9 upon 36 pi farad per meter, or K giving value to be 9 into 10 to the power 9. So value of K is 9 into 10 to the power 9 in SI units we are considering. So this is the value of constant K, constant of proportionality. Now the same law we will discuss now in vector form. So again, let us see that with respect to origin, two charges are placed, Q1 and Q2, at the positions R1 and R2. So in vector form, we will see that what will be the expression. So we express here force F12. So F12 is the force on charge Q2 due to Q1, and similarly F21 is the force on charge Q1 due to charge Q2. So as per this law, in vector form, force F12 we are writing first. So 1 by 4 pi epsilon naught Q1 Q2 upon R square, and we will place a unit vector here. We know force is a vector quantity. So here unit vector R12 has been placed here, and vector R12 is having magnitude R, that is distance between the charges Q1 and Q2, and as per vector algebra, R12 will be given as R2 minus R1. You can see from the diagram, that is this one, you see this triangle. So with the vector algebra, we can write that R12 is R2 minus R1, and by definition, unit vector R is R12 upon R. That's how we write a unit vector. So in vector form, for the expression F12, substitute the value of unit vector R here. So this will result into this relation, that is 1 by 4 pi epsilon naught Q1 Q2 upon R cube R12, where R12 is a vector and direction is as per the diagram, as we can see. Or we can write in this form here, because magnitude we are writing as R2 minus R1 magnitude, and similarly vector R12 is R2 minus R1. Vector R12 is R2 minus R1. That value we are writing here. So either we use first form, first one, or second one, or third. All these are the vector form of the Coulombs law. So this is giving us the magnitude and direction both. We can find the direction and magnitude both of the force exerted from one charge to another charge. F12 and F21, they are equal and opposite, as we know. So that means unit vectors AR12 is equal to minus AR12. This unit vector you can write in the previous form, that is, you can write like this, R12 equal to minus R21. So these are the unit vectors. So F12 will be equal to minus F21. Rest of the thing will be same, only direction will be different. So important to note is that like charges repel and unlike charges attracts. In this law, charges should be point charges, that is, R should be large as compared to the dimensions of Q1 and Q2. So these are point charges, and Q1 and Q2 are the static charges here. That is, we are considering the situation to be static. There is no time variance here. So under static conditions, we are writing this law, and we are writing expression for the force between the two charges. Now, if a system is having number of charges, that is, we are having a system of charges basically, there is not single charge. In that case, principle of superposition will be used to find the net force. So how it is used? Let us see. So we assume that we are having a system of charges having charges Q1, Q2, Q3 and Q1, and their positions are respectively R1, R2, R3 and Rn. So positions of charges Q1, Q2, Q3, Qn are R1, R2, R3 and Rn. Then according to principle of superposition, according to Coulombs law, the resultant force we have to find. So principle of superposition we will be using. So let us see the resultant force F on a charge Q which is located at R. Resultant force on a charge Q which is located at the position R. So what will be it? It will be the vector sum of all the forces as per the principle of superposition. So let us see the net force. So first term as per Coulomb's law in vector form, Q1 upon 4 pi epsilon naught R minus R1 and R minus R1 Q. Similarly, you see the second term. This is for this force due to the second charge, that is Q2, force between Q and Q2 and so on. And the last term is the force between Q and Qn, where the nth charge is located at Rn. So we can express this in the resultant form, that is this one. So F is Q upon 4 pi epsilon naught summation K1 to N Qk. So here K is representing the number of charge. So here value of K is 1 to N. And kth charge is located at the position Rk. Kth charge is located at the position Rk. So thank you students. I hope it will be clear to you that what is the charge, how it has been established, and the fundamental law, Coulomb's law, that we have seen in this video. Thank you very much.